this two-step equation slide. And we went through each of these steps, and what we really did was we came down to this process which said we want to get letters on one side and numbers on the other. We always do inverse operations. We always make sure we do the same thing to both sides of the scale. If we do that, and both sides of the equation is because it's like a scale, then these things settle each other out. Those are your basic fundamental two-step equations. If we could make every equation like those two-step equations, I'm sure you would be very happy. You would get outstanding grades in the class because most kids feel that they're pretty easy. Well, the truth of the matter is that rarely are things ever always so easy. More often they look like these kind of equations, even a little more complicated. But I wouldn't let that bother you because our job is to make them look like those simple two-step equations, and we can do that pretty easily. You have to become part Columbo and part Peyton Manning. I remember when I first watched Peyton Manning play football, he used to walk up to the line of scrimmage and he would start, the quarterback would go like, hut, hut, hike. Well, Peyton Manning would look at the field and he would start pointing, as he is in this picture, at different defenders. And what he was doing was he was audibling, an audible is when they change the play, to the proper play that could beat the defensive alignment. Okay? Well, there are some techniques that work with some equations and some techniques that work with others. Think about it, Peyton Manning. Let's say that the defense puts everybody in the same spot of the field, right up in front of the line, right in front of the center. That's the guy that hikes the ball to Peyton Manning. And Peyton Manning calls a play where he gives the ball to the running back and he runs right into that wall of 11 guys standing there. Well, that's not going to work. It's going to be an unsuccessful play because it's just not the right play for that kind of defense. Now, if the defense is like that, Peyton Manning should call a play that goes to the outside, maybe a quick pass play. So he would go up to the line, he'd see everybody there, and he'd say, okay, because it looks like this, I'm going to call this other kind of play. And then he would audible at the line. He'd tell the team, hey, he'd go like, blue 21, 17, 17, 17. And he's making sure everybody knows that he's calling this play 17. And then he would go hut, hut, hike. And he would get the ball, and then they would run this play that was designed to prosper against that defense. Well, your strategies with solving equations have to be designed to prosper against that equation. Columbo, part Peyton Manning. Now, what I want you to notice here when I look at this is that in this first equation, the variables are on the same side, okay? Whenever they're on the same side, the variables being the x, whenever they're on the same side, we will always do the same operation. Now, I have many great gifts. I can really fly fish. I was a pretty good athlete in high school, not a great one. I got great grades. I can take a decent picture, get along great with dogs. I have a lot of really fortunate gifts in the world. However, I have some things that I cannot do at all. One of which is sing. I was cut from a church choir. Can you believe that? Absolutely was. I went into the church. The lady was playing piano. She hit a note all the way on the left, and she goes, sing that note. And I went, and she said, all right, let's try this one in the middle here. She hits that one. I go, and she goes all the way on the right and does it again. I go, she goes, yeah, the church needs help with other things. Go figure, right? I mean, terrible. Did years of damage. Psychotherapy, anything to try to get over that moment and the blow to my self-esteem. I could have been the next Bruce Springsteen. So I would always have my classes sing this, and I'm going to sing it for you now. So if your ears hurt, I understand. I would go, same side, and the class would go, same operation. So every time you see same side, you got to think to yourself, same operation. Same side, same operation. What I mean by that is this. If you take a look at this, the 5x and the 3x are on the same exact side of the equal sign. Whenever they're on the same side, you're going to do that same operation. And in this problem, that same operation is the add here. So what is 5x plus 3x? That is 8x. And that changes things to a simple two-step equation. Once I realize that when the variables are on the same side, the 5x and the 3x, I add them up and I get the 8x. 8x minus 9 is negative 25. Notice everything else stays the same. The minus 9 equals negative 25. I didn't touch those. I just simplified. I said whenever I get the variables on the same side, I'm going to do that same operation. And this is a big adjustment because before we did the opposite operation. But we'll talk about that in just a minute. Since the x's are on the same side, we do the same operation. And what that means is 5x's plus 3x's is 8x's. And now I do the standard two-step solution technique. Notice here, this is very important for what we're going to come to. These numbers are on opposite sides, the negative 9 and the negative 25. So when they're on opposite sides, you're going to do the opposite operation, which we'll talk more about in just a minute. That says minus 9, you do plus 9. Plus 9 to both sides, of course, always to both sides. I didn't do the 5x plus 3x to both sides because they were only on one side. In other words, they were just on the same side, so we do the same operation. So I don't worry about both sides in that case. Alien abduction, whatever you want to call it, cancel, die. Negative 9, positive 9, they wipe each other out. On the other side, negative 25 and 9 is negative 16. Then I divide both sides by 8, and I get x is negative 2. Booyah! Now let's look at the one on the right. Should look very different to you. Are those ends on the same side of the equal sign? No, they are not. Here's your equal sign. Drawing a little imaginary line up and down the middle. The ends are on opposite sides. So when they are on opposite sides, you do what we call the opposite operation. Now, the first thing I did here is I took a little for granted, and I hope you remember this. This is something that you start teaching in 7th or 8th grade, at least in New York schools. It's called distribute. So when you see a number outside the parentheses, you multiply it by everything inside. 2 times 2n is 4n. Remember, distribute means to give out. 2 times negative 5 is negative 10. So that gives me the second line that just says 4n minus 10 equals n plus 11. And in here, that's what I wrote on red just above it. Opposite side, opposite operation. Opposite side, opposite operation. So when they're on the same side, like over here, 8x and 5x, 5x and 3x, you add up and get 8x. On this other one over here on the right-hand side, these ends are on opposite sides of the equal sign. So when they're on opposite sides, I do opposite operations, and it's most convenient, you don't have to, but it is most convenient to always begin with the smaller number of n's. So that says plus n, so I do minus n to both sides. So we do minus n to both sides, and when I do that, what's 4 n's minus an n, or 4n and a negative n? That's 3 n's. I don't touch the negative 10. I didn't do anything with that because you got to put your like things together. N's go with n's, numbers with numbers, and so on. Now it looks like a standard two-stepper. Look at that. 3n minus 10 equals 11. That looks just like the previous slide. The opposite of minus 10 is plus 10. Notice the numbers are on opposite sides. So for the numbers, I did opposite operations. I don't care if it's the letters that are on opposite sides, like the minus n and the minus n, or the numbers that are on opposite sides, like the plus 10 and the plus 10. Whenever they're on opposite sides, we do opposite operations. So alien abduction, Sasquatch, squished them, whatever you want to say. Adding 10 to both sides, negative 10 and positive 10 add up to 0. And then I divide both sides by 3, and 21 divided by 3 is 7. So the big thing we learned on this side is that just like Peyton Manning goes to the line of scrimmage and he looks for where the defense is so he can call the correct play, you have to look to call the correct play. And what that means is you're going to survey the problem like Columbo, but like Peyton Manning, you're going to make an audible. And you're either going to tell your side, same operation, because the variables are on the same side, or you're going to go, no, they're on opposite sides. Opposite side, opposite operation. Now, those are the fundamentals for how we handle this stuff. All right, let's see you try these two on your own, and I will then go through and solve them with you step by step. Go ahead. I'm going to go further. I'm going to give you 4 choices for answers. 2 of them do not solve either equation. So as you look at this, 2 of these choices don't solve either equations. That means 2 of these choices are correct, 1 for each equation, and 2 of them are wrong, 1 for each equation. Keep working them. Well, you actually had the time to pause the videotape. Let's take a look now and see what we come up with. Oop. In the case of the first problem, I'm going to get 9h minus 9 equals, that same side stuff actually applies to the 23 plus 4, that's 27. So same side, same operation is the correct strategy here. 5h plus 4h is 9h, minus 9 equals 27. Adding 9 to both sides, I get 9h equals 36. X is 4. So we know that 4 is one of the correct answers here. It's allowed, I can't believe I didn't show step by step here. I apologize. We're just going to have to do it verbally. And then on the equation on the right, your first step should show distributing 3. So it should say 3k minus 15 equals 7k plus 1. You notice the k's are on opposite sides. So now you're going to subtract 3k from both sides. Remember what I said before, start with the smallest k's. And you get negative 15 equals 4k plus 1. Then you're going to minus 1 to both sides. You get 4k is negative 16. Dividing by 4k is negative 4. So the two that work are negative 4 and positive 4. Okay. Sorry I don't have the steps there for you. But we will, at some point, not too distant future, be able to go over that. Very similar questions. Okay. Now, solving linear equations. Speaking of opportunities to check, when you look at this, if you're Peyton Manning coming up to the line, what do you notice right away? Is this a same side situation or an opposite side? That is to say, do you have letters that are on the same side or numbers on the same side? Well, I see letters on the same side. So let's put, like on the left-hand side, you have letters that are on the same side, and on the right-hand side, you have numbers that are on the same side. So make sure you get all your X's together on the left side, all your numbers together on the right side, and then keep on working. Okay, I'll pause. You do a stop and start now, and then we'll go over the correct steps. So when we put the X's together on this left side here, 3x minus 4x is negative 1x, which we just read as negative x. And then on the other side, what we notice is that 1 and 12 can be combined to make 13. You don't have to do that step, but it makes things a little easier if you do. I know this is review for most of you, so it's really not that big a deal, and I'm not going to beat myself up over not having the steps written out for the previous two problems. Now, always start with the smaller number of x's. Negative 2x's is smaller than negative 1x's. So I do the opposite. I add 2x to both sides. Wow, look at that. When I get to the step that says 5 plus x is 13, now I have a standard two-stepper. I just subtract 5 from both sides, and I get x is equal to 8. Okay? All right, so I think this is good enough for this particular video. This is some fundamentals we put in. If you're not understanding this so far, it's really important that you go back and watch these steps to learn how to solve these problems. Both standard two-steppers, same side, same operation, opposite side, opposite operation situations. If you can get that, you're in really good shape. And then as we proceed forward, these problems will be pretty routine for you. Okay?